In this video, we're going to be taking a look at a momentum and impulse problem where we have a ball bouncing on an angle, hitting the ground, and then bouncing back up. And we're going to find the impulse along both the axes in the horizontal and vertical direction. So just like anything with an angle, it has a vertical and horizontal component or an X and Y component. So for example, this 3 meter per second vector at 50 degrees has a vertical component going downwards, and then also has a horizontal component going to the right. And then once we close up that triangle, that's going to be helpful in helping us find some different components for that velocity vector. Same thing for the 2.5 meters per second bouncing upwards 60 degrees above the horizontal. It has some horizontal component going to the right, and then also has some vertical component going upwards. So if we use the tip to tail method to close off that triangle and find those different components, then we are good to go to start solving for our different components. Now, for the component over here, it is in the opposite direction of our angle. So we're going to want to use sine so that we can utilize the opposite end and the hypotenuse in order to find our component. So this one would be sine of 50 degrees equals the opposite. So we'll call that Vy over the hypotenuse of 3. And then multiply both sides by 3. And then our Vy comes out to be 2.3 meters per second. Now, when I place it over here, because it's a vertical component, I'm going to put negative 2.3 meters per second to make sure that it's showing the ball is going in the downward direction. Now for the other one, it's going to look very similar, except I'm going to replace that with 60 degrees. There's the y component. And then that velocity for our second vector is 2.5. Same thing, multiply both sides by 2.5, and then I have a Vy of 2.17 meters per second. And that one, I can leave it positive because it's going in the upward direction. Now for the two horizontal components, very much the same process, except we're going to use cosine instead because we want the side adjacent to the angle. So let's go ahead and work those two out. All right, so from there, we can use the impulse formula, mass times delta V, and delta V is the final minus the initial velocity. So let's work that out for the horizontal components. I left both of the horizontal components positive because both of them are pointing to the right, and we'll call the right positive direction, we'll call the left negative direction. So everything is positive for our two horizontal vectors. In that case, we have a mass of 0.5. The final velocity is our 1.25 minus the initial, which is 1.93. Subtract those two, multiply it by 0.5, and then we get negative 0.34 kilogram meters per second for our impulse in the horizontal direction. That comes out to be negative because we have a force of friction that would be pushing up against the ball in the negative direction in order for that impulse to occur. Now for the blue ones, our vertical direction, we have a mass of 0.5 still, and then we're going to take our final velocity of 2.17 and then subtract our initial of negative 2.3, which is basically just adding the two if you're subtracting a negative. And then we get a final impulse of 2.24 kilogram meters per second. Now you notice this impulse is much, much larger than the horizontal one in red, because for the blue one, basically what the ground is doing to provide that vertical impulse is it has to completely stop that 2.3 meters per second of velocity and then fling it upwards at 2.17. So that's a much greater change in momentum, therefore a larger impulse. So when working on a problem like this, you want to make sure you draw your triangles, get your vertical and horizontal components by using a little bit of trig, and then from there, just making sure you use your momentum formula, delta P equals m times delta v, the vf minus vi, and then you can get your impulse in both axes. So if that was helpful to you, thank you for watching and listening.